welcome to Arlington Woodworks. I'm Jesse Arlington, your host for today. In today's video, we're going to be rebuilding this old mortising jig. Before we get into building the new jig, I want to walk you through sort of the setup of the old jig. It's pretty simple, but it's worth sort of doing a quick overview, and I'll explain to you why I'm building a new one, because this jig actually worked just fine on a number of projects, but in a second you'll see why we're building a new one. Effectively, you just loosen these handles, and that allows you to adjust the position of these sideboards, as you can see here. And this thing's not functioning very well because, well, I'll just go show you what happened right now. I dropped it and it snapped in half because I was not careful. And so this is what happened. So it doesn't really work very well. So the way this works is, if you got a workpiece and you've laid out your mortise, this is just a piece of cherry that I had sitting on my lumber rack, and you figure out where your mortise is, you can lock these, and this side doesn't slide because it's broken, and that's why we're remaking it. You can lock these in place on the sides of the wood with a router mounted here, which I'll show you as we go build. And then this allows you to slide the router and create a mortise with the bit so that it's perfectly straight. And if you want to get it centered, once you've cut that, you can flip it over and then cut the other side of the hole, which I will demonstrate all of this at some point once we got the other jig built, but this one is not usable at this present moment. So in order to fix this so it's better and so that it's a little bit more resilient, I'm going to redesign it a bit. Not by much, but I am changing a few things. I'm going to replace the 1/4-inch piece with this piece of, I believe this is 3/8-inch aluminum, which we're going to have to lay out. And then we're going to replace the rails with these 3/4 by 3/4 inch square aluminum. Effectively, the router will mount on top like this. I've got to decide the orientation as far as comfortability of use of how I want to mount the router. That'll decide the location. Once we've decided the location of the router, then we can determine exactly our process for getting everything milled up and getting it all assembled and then putting it to use. We'll have to take this plastic plate off of the bottom of the router and then reuse this hardware. So the plan there is, once we figured out where we want a router to sit, we'll use this as a template. We'll use a pattern bit in here to route out a hole in the aluminum, and then we'll transfer our screw holes here so that we can attach this plate to the bottom of the router, and it'll be all locked in place, and then we'll get our rails attached. So that's the plan. We'll see how it goes. I like to do a lot of my routering here at the workbench. I use my tail vise to hold my workpiece in place. So what we're going to do is we're going to sort of mock this up. We're going to put a piece of wood in the clamps, and then try some different positions with the router to determine, is it more comfortable to hold the router this way? Would I be more comfortable holding the router this way? And this is going to drive our decision on how we orient this on the plate in relation to our rails. So, it's really a matter of personal preference, I think. But for me, it's more comfortable to go this way to move the router across the workpiece than it is. So this is a push-pull motion vise. This way, where it's a side-to-side motion, I just feel like I have more control of the router this way. So we are going to set up the jigs in this orientation. So we'll move back over to the other bench now that we've sort of tested this out and seen how we felt comfortable with the router, and we will start laying out our aluminum plate to figure out exactly how we want to get it set up. The workbench with the router. So just to walk through what we discussed over at the workbench where I'll actually be doing my routering, is we determine the orientation of the router to the plate. So in this orientation, which you might be saying, hey, if you turn it that way, it's the exact same orientation on the plate. You would be correct. But what we really determined was the position of our rails associated with the router. So you're looking at me straight on. We decided we wanted to push-pull the router, so therefore we're going to orient the rails in this orientation to allow us to clamp to the workpiece this way and slide the router back and forth. The first thing we're going to do is remove the plate off the bottom of the router, which I talked about before. That's going to allow us to use this as a template for our plate. There's a few different ways that we could divide this up to ensure that we've got the exact center. I'm not super concerned that it's at the exact center, but I do want to have it pretty close. So what we're going to do is we're going to use this speed square on the 45 degree to ensure that we've got it lined up at in the center of the workpiece. So in order to do that, we just line one end up with the corner, scribe a line. I don't know if this is going to show up on camera or not, across, and then we do the same thing from the other corner, line it up exactly to the corner, and then scribe a line across. And I'm scribing this line relatively long for a specific reason. And then now we know that right here is the center of our plate. So now we've got it centered. We need to mark out the location of our holes. So we're pretty close to center. So now we can use our drill bit. We'll hold the piece in place and just give it a tap. I do all three at the same time, otherwise we have risk of moving the plate. Tap. So what that's going to do is that's going to transfer the center of these to the plate so that now we know where to drill. That was pretty easy. So now we just got to find our next hole. So it's critically important when you're working with metal, especially, it also plays in when you're working with wood, is to make sure that you use a punch mark to start your drill bit. The brad point bit did a pretty good job, but I'm just going to make this a little bit more defined. Our other one over here, make it a little bit more defined. So what that does is it provides a starting point for your drill bit so that it doesn't wander on the top of the workpiece. It's important that these holes end up accurate to where they're supposed to be. Now that we got our holes drilled, we can temporarily attach our plastic plate to the workpiece, or to the base plate. Got to figure out our orientation. We marked our holes, which something is off here. When we marked the holes, I had flipped the plate over in order to transfer the mark because it's a tapered hole, so I wasn't sure that I was centered, so I had a better chance of getting it centered. So that's why I had so much trouble there trying to figure out how I had this aligned. So this is important that we recognize this now, because we want to make sure that when we countersink for our screws to come up from the bottom, that we do it on the right side so that we can attach the plate. So now that we've recognized that, what we'll do is we'll note our orientation. We are going to flip the plate over and set our router plate on this way. So now we're all lined up with all our holes. I've got some temporary hardware that I'm going to use. I was only able to find 2 of these to secure this to the base plate. Whew. sharp metal. All right, so what I did was I routed out a hole that would be large enough to put the pattern bit into. Okay, we're gonna vacuum again before we keep going, but we have initial success. Pick up your headphones. So we didn't quite plunge all the way through, so we'll lower the bit a little bit more. We'll make it so we're plunged all the way through. We're about a 1/16 of an inch off. We're gonna clean up this mess and then do one last plunge, and we will have our hole cut in this. And I'll take it over back to the bench, take the plate off, and show you what we accomplished. But first, let's vacuum. Oh boy. Recommend wearing long sleeves when doing stuff like this, just because, well, I'm hairy, so it gets all in my arm hair. So the sleeves protect me. Probably would be beneficial to wear gloves as well. All right, we'll make a couple of adjustments to our depth, and hopefully this will be the final pass. All right, and like I said before, clean as you go. It makes the job easier at the end. If you hit this the right way, it comes off too. So, all right, we're gonna take this over to the workbench and discuss what we did. All right, we're back at the workbench, and I don't know if you could see it while we were over at what I would call the workbench. This is really the assembly table. We routed out a hole in the center of our plate. So we bolted the old base plate onto our new base plate and used it as a template to router out a hole. So we'll take off the old base plate and set it aside for now. Okay, so there you have it. Our base plate is basically prepared for accepting the router. So now when we go to mount the router on, which remember, this is the bottom, it won't be this orientation. We'll be able to center it on that hole and be able to plunge the router through that hole and router our workpiece. So, router's kind of heavy. All right, so in order to reuse our hardware that was attaching our original base plate, you can see it's called countersunk or counterbored into the base plate, and it sticks out enough to attach into the bottom of the router. I had some other bolts that fit in here, but the standoff of the bolts was too much. So I'm going to use the original ones, even though they seem really short. So in order to accomplish that, I'm gonna have to counterbore into our base plate. So we'll double check orientation, make sure that we have the right orientation as far as which side we're counterboring into, so that we counterbore into the bottom so that the bolts can come through. I'm gonna figure out our plate orientation, make sure we got our top bottom correct. So this is the top of the plate. So we want to flip it over to ensure that we don't drill our holes in the wrong place. I do have all right, so this is the bottom of the plate. So we want to transfer these holes down into the plate. So I'm gonna do something to dramatically mark this so that I know it's the bottom of the plate and I don't make a mistake and accidentally drill holes in the wrong side. So I'll be right back. All right, we've checked our orientation. I'm gonna mark this with a piece of painter's tape and the right bottom on it so that I don't make a mistake. we got it back in there. All right, so we have now counterbored our 3 holes. None of them actually look very good, but I think it's going to do the trick. So now that we have our 3 holes to the appropriate depth, I'm going to attach the router to the base plate to make sure that everything so far is going well. Once we get that sorted, then we'll shift our focus to attaching the rails. All right, now that we have the router attached to the base plate, we can decide the position for our slots to be milled out for the rails to attach. I think we're going to go with 2 inches. That gives me the maximum amount of material on this side and still enough maneuverability with these clamps on this side. So we're going to take this measurement of 2 inches and we're going to set up our router table with our 5/16 router bit to mill out these slots. So we'll move over to the router table and get that set up. All right, so I screwed up my recording. So what I'm going to do is show you what I did. I measured the position of the location where I wanted these slots. I've got these 2 milled out. I'll show you me milling out the next 2. But I put a stop block for a start and a stop block for a finish. And then I was having some issues with the sawdust collecting. It's not sawdust, aluminum dust collecting at the end there. So I didn't want it to hinder finishing out the length of the router. So I've got my vacuum clamped to my stop block. And so it looks a little crazy. But we're going to run through this and make it work. As you can see, we've routed out our slots. We left a tab in the middle. It's going to provide some additional support to this outside piece of the plate. If we had that, there may be a little extra room for flex. Probably not a big deal, but I wanted to be sure that we made this as structurally sound as possible. In order to mark this, we're going to use a brad point bit like we did before and a hammer. So set the rail in place. I'm going to ensure that it's square so that they're centered. I'm going to set them on either side. Get the combination square, which I don't have here, to ensure that these are square, flush with the edge. Feel that with our fingers. Go grab my combination square. The combination square is going to allow us to square these up against the outside edge, which is what we squared our plate against. So we know that this back one is square. We got to find the 5/16 bit. It's not that one. It's this one. But before we do this, this is why you got to think your projects through. We should mark the center line on our rail so that we ensure that we're centered. So the rails are 3/4 of an inch. Let's verify that real quick. So 1/2 of 3/4 is 3/8, which is a good way to sort of mark our center. And yes, we're in fact 3/4 of an inch. So if we go with 3/8 of an inch, that'll be our center line. We're going to want to do this with a scribe vice a pencil, probably. But a pencil is all that I have right now. So I'm going to mark our center line. Whenever I'm doing this, I like to do it from both sides, because I know the pencil gives me an inaccuracy, so that gives me an idea of sort of where the center is of the board. This is aluminum. The center of the aluminum. So probably can't see it on camera, but there's probably an 1/8 or a 1/16 of an inch between my 2 lines. Like I said, some of that's due to the inaccuracy of the end of the pencil offset off the edge of this. So I'm going to make a slight adjustment to this. Now that we've got our center line, we can draw it on each of these, and we know that we milled our slot at 2 inches, so we want to be able to see it through the slot. So we want to make sure that, so this is 2 inches from the end, our line is here. Do the same over here, figure out sort of 2 inches, is it right around there? So we can mark our slot here. Just want to check to make sure, yep, we're good. Do the same thing on this one. And so now that we've got these marked, we'll set them back under the plate, and then we'll use this in combination with our brad point bit to punch a mark for the where we're going to drill our hole. Now we've got our center line on our rails. We've got our this back one we'll start with, and then we'll square up that one. And we want to try to do both at the same time. Flush at the end and squared to the plate. We can drop our brad point in on our line. Get it vertical. Give it a little tap. So that marked our center. Let's just double check to make sure we didn't knock it off square when we tapped it. I tapped it pretty hard. Oh, it's still good. Do the same thing on this side, and then we're going to make that center punch mark a little bit more defined with a proper punch, but this gives us the center of the hole. So we're centered on our rail, we're centered on, or we're square to the plate, and we're centered on the slots. So now that we got the back one done, we'll get the front one done. Drill the 5/16 hole, which allows our bolts to pass through. I know that I can cut this aluminum on my table saw, so what I'm going to do is figure out sort of the depth of cut to get this head sunk in, and then we're going to cross cut it. It is going to leave a notch out here, or a dado across, which is going to be fine for what we're doing. So what I'm going to do is I'm going to put the bolt through. I'm going to mark on either edge where the saw needs to sort of cut in, and then we'll adjust our height. Okay, now that we've got our first cut made, we're going to find our other line, line everything up, make that cut, and then we will cut everything else out that's in between those two. Pretty clean bottom to our hole. Drop the bolt in, make sure it clears both sides. It does. It's a nice fit. I think we're in pretty good shape here. So we're gonna do this to the rest of them and head back over to the workbench. Now that we've got our slots milled out, we can test fit our rails into our base. Right. So that's a bit of a tight fit. I think the holes might be slightly off, which is excellent. So we'll go ahead and try my other one, see where this is, how this ends up. that one fits a little bit better. I'm gonna have to make some minor adjustments to these. All right, now we'll fit the plate to the bottom of the router. There's the 3 mounting holes that we aligned everything to earlier. So I'll just visually check to make sure that I've got this oriented the way that I want it, which ends up being something like this. We'll line up the holes visually, and then we will install the screws. All right, so back here at the workbench, we're gonna clamp a piece of scrap material into the tail vise. That just keeps it in place, stable, and we're gonna try to test out our jig and see how we did. So remember, we decided we wanted it to go, fore to aft. That's a sailor term. I was in the Navy, what can I say? We wanted to go, instead of pushing it side to side, we wanted to push it front and back. So what we do is, we're just gonna imagine that we lined up a mortise in this piece, and we're gonna adjust our clamps. Now it's nice and secure. I'm gonna put on my PPE, and we'll plunge a little mortise. All right, so I wasn't worried about the depth setting since this is just a demonstration, but I do want to show the advantage of this. So I didn't center this mortise at all whatsoever, and it's barely a mortise. It's hardly cut in there, but it's not centered. I can tell it's not centered visually looking at it, but the advantage of this jig is because these 2 rails are parallel to each other, I can turn the jig around, plunge and cut the same mortise, and then it'll be perfectly center. So I always cut my mortises prior to cutting my tenons to avoid any sort of mismatch, because it's easier to make a tenon thinner than it is to make a mortise thinner. So let's center this up, and then I'll show you the workpiece, and maybe we talk a little bit more about the project and wrap this thing up. All right, I am more than happy with that result. So we got a nice mortise. You'll never see the little burn mark there at the bottom of the mortise. Like I said, we didn't lay this out or anything. We were just doing a scrap piece. So the advantage is, and I got another project coming up where I'm going to use this and I'll talk through it, is typically once you've laid out your first mortise, figured out exactly where you want it to be, you can just mark 2 lines, and then you plunge at each end and then route across, and flip it around and then route it so that it's centered. And then all your mortises are cut exactly in the same orientation, same spot every single time. So overall, I have to say I'm pretty happy with how that turned out. Boy, was it a journey to get this far. Oh, now that we've successfully conducted a test cut, I'm gonna take it apart one more time, remove the plastic from the aluminum sheet here, and put it back together and get started building some projects. So the old jig was made out of wood and MDF. I dropped it, it cracked. Had a few different issues with it as far as mounting it to the router and other things. These T-handles would crash into each other, so I opted to go with these cam clamps on this one. We'll see if I like them over time. If not, I might go with some smaller knobs, but got a lot of considerations for that at this time, because they may hit the base of the router itself, which would be a problem. So for now though, I think that we can call this project done. Thanks for sticking with me all the way to the end. This project was a bear. I know it looks pretty simple. We just cut a hole in a piece of aluminum, drilled 3 holes in it, cowder bored them, milled some slots into it, and attach some rails. But when you got a wood shop that's set up for working with wood and you start to work with metal, you quickly run into challenges in not having the right tools for the job. So we were able to work through all those problems and get to success. So now that we've got this done, we can start using this for future projects. All right, thanks for sticking with me.